Let us now study about some applications or uses of beats. There are many applications. What is listed here is only few of its important applications. First one is to find the unknown frequency of a tuning fork. For example, let's assume that there is a tuning fork whose frequency we know, which we call as F. This is a tuning fork of known frequency, and there is one more tuning fork whose frequency is unknown. Let us call that frequency as f dash. Here the frequency is unknown. We need to find this frequency f dash using this frequency f, using the principle of beats. To understand this, let's assume that both are like tuning forks like this, and both are sounded together. Now, in this case, if the number of beats heard is 0, then it means that two frequencies are same, because the beat frequency was defined as difference of the two frequencies. Here, if suppose when they are sounded together, and in that case if some beats is heard, it means these two are different frequencies. For sake of argument, let us assume some numbers to this. Let this frequency be, say for example 420 Hertz, and this let us take as 416 Hertz. Just a rough example. Now, when both of these are sounded together, then difference of these two would be 4 Hertz, and therefore what we get would be the beat frequency is FB 4 Hertz. But now in this case, what we'll do here is, if only 4 Hertz is heard, then there are two possibilities. That is, this frequency could be 416, or it could be even 424 Hertz. Both cases we would get the same beats as 4. So just by knowing the beat frequency, we can't tell which is greater. So in that case, what to do is we put some wax on any one tuning fork. For example, if we put some wax onto this tuning fork, then its frequency will decrease, because frequency is d by lambda is given as b is given as t by mu to 1 by lambda. So f dash is equal to 1 by lambda t by mu. Mu is called as mass per unit length quotient of a T is called as tension in the forks. Therefore f dash is proportional to 1 by root m. By putting some wax onto this, mass has increased, so frequency would decrease because mass has increased, which means the frequency would decrease. So the possibilities are, it is either 416 Hertz or 424 Hertz. By applying wax onto it, frequency will decrease. Let's assume that it decreases to 415 Hertz, and this decreases to 423 Hertz. These are just rough numbers, not to be memorized. Now again, if this frequency f and this f dash sounded together, then based on beats we can tell what is greater. Suppose if the beats decreases, that is, if the beats become 3, and what happens, it means that the frequency was higher, because if a beat decreases means it becomes 423, then f dash was higher. In that case, we can tell that f dash minus f was the beat frequency. Suppose if it was, say, 416 Hertz earlier, and by putting some wax onto it, it becomes 415 Hertz. So if 415 Hertz is sounded with 420 hertz, then what we get would be 5 hertz. Means when the beat frequency increases, means that the frequency was a lower value. In that case, you can say that f minus f dash the beat frequency. So by this way, you can find out frequency of the unknown tuning fork. The first method, first use of it. Second use is musicians use beats phenomenon in tuning their instrument. Suppose a musician wants to tune his instrument to a particular frequency, say for example 512 hertz. Then the person can sound or can keep changing the knobs or ends of instrument by resonating this with a known tuning fork frequency. So when both the known frequency and the wire are sound together, beats will be heard. The person can keep on tuning until no beats are heard. So in that way, person can tune his instrument. One more use of it is that beats are also used in detecting poisonous or dangerous gases in mines. Understand this. Example, think of a mine like this, and if the mine contains a lot of gases, imagine some are this dangerous gas, then we can take two pipes, and in one pipe we can fill air which is pure, that is air around us, and we can fill some gas from this into this pipe. Now suppose if the air was pure and if we set them into resonance, then these two will have same frequency. That we call this as frequency of 1 and frequency of 2. So this air column or this tube contains air from this mine. If the air from mine is pure, then when these two are sounded together, there won't be any beats heard. But if there is beats heard, means that the air from here contains gases other than the air around us. The air around us is pure, but mines contain many poisonous gases. This is an indication tell that mine contains some poisonous or dangerous gases. My use is that beats are used to produce special effects in cinematography. There is no need to understand how it works. Just remember the basic uses of beats. Out of this, most important is find the tuning fork of a and to find the unknown frequency of a tuning fork where there will be numericals based on